Okay, good morning. Is the screen visible?
No. Yes, sir.
Okay. So today we'll start with the second application of the ordinary differential equation, and the application is for the simple circuit. Before we start with the actual topic, I'll just recall what you already know. The first one is resistance. It is denoted by capital R, and in the circuit, the notation is like this. In case the current is uh, resistance is R, positive, negative, and the unit for this is ohm. Okay, and this is how it is denoted. Then resistance, inductance, inductance, abbreviated or the symbol capital L. Diagrammatically is denoted like this. This is L, positive, negative. Inductance is calculated in terms of Henry, and H, how Henry is given. Next, resistance, inductance, and the next one capacitance. Capacitance is C. Diagrammatically, it is denoted by two parallel lines. Capacitor in the circuit is given by C, positive, negative. Capacitance is calculated in terms of farad, is abbreviated as capital F. And then electromotive force or voltage, EMF, is denoted by capital E, diagrammatically given as a smaller line and a larger one, negative, positive, and the unit is volt. So these are the symbols that we'll be working with. Then the relation between current and the charge. So Q is the charge, I is current. So relation between the charge and the current, anyone?
Sir, Q equals to IT.
In terms of derivative?
Sir.
dq by dt. I equals to dq by dt.
So currents?
Sir.
Yes, wait.
Sir,
I
can you take
is equal to dq by dt. So rate of change of charge is nothing but the current. Yes, what you were saying, can you take?
Sir, can you take to the previous slide? Yes, sir. Done.
Then the first one is the second. Voltage drop across the resistor. Voltage drop across the resistor is equal to, yes, anyone? Voltage drop across a resistance R.
So dq by dt into r.
dq by dt into R, yes, exactly, which can also be written as R into the current I, which is R into dq by dt. Second, voltage drop across the inductor or the inductance, capital L. Yes. No one? Rashi,
L di by dt.
L into di by dt. And the last one, voltage drop across the capacitor. Voltage drop across the capacitor. C.
Q by C.
Q by C.
So di by dt by c.
Are you sure? Di by
So
dt.
q can be written as di by dt, no?
Not Q is
No,
written
no,
as
no.
Q.
Sorry. It's wrong.
And the fourth remark that we want to recall is Kirchhoffs voltage law. This you may have seen in LADC in the applications of matrices. There you may have recalled this. Yes, anyone? Sumed? Tanmay Jain? So the Kirchhoffs law for voltage states that voltage drop across any closed circuit is always equal to the resultant electromotive force. This law plays a major role in forming the differential equation. So the law states that the algebraic sum of voltage drop across any closed circuit. Any closed circuit is equal to the resultant electromotive force. In the circuit. Okay. So whenever we will have an electrical circuit, say, which has a resistance R and an inductance L, then using this law we will form the differential equation out of it. If in a circuit we have a resistance and a capacitor, then we will have our differential equation using the Kirchhoffs voltage law. So first of all, we'll study the circuit which is involving resistance and an inductor. So circuit, or simply I'll write it down RC circuit or RL circuit, that will be better. So RL circuit is more commonly encountered circuit in our example. So I draw the circuit. So this is resistance, this is the inductance L, this is the applied electromotive force E, negative, the current. What does the Kirchhoffs law states? Kirchhoffs law states that whatever the voltage drop across the resistance is there, the voltage drop across the inductance is there. So summation of both of these will be equal to the applied electromotive force. So now voltage drop across the resistances by Kirchhoffs law. What is the voltage drop across this R? What is the voltage drop? I
IR.
R plus the voltage drop across the inductance is L into di by dt. And this total voltage drop across this circuit has to be equal to the applied electromotive force. So what have we got? So L into di by dt plus R into I is equal to E. So this is which type of differential equation?
Linear, sir?
Which differential equation is this? Someone said you have studied this. Please be quick.
Sir, linear?
A linear differential equation, exactly. So this is linear differential equation. You have the formula to solve it. Linear differential equation. What do? You first of all find the integrating factor. Once you get the integrating factor, then what is the formula? Y into integrating factor is equal to integration E into integrating factor plus C. This you have seen in the previous lecture. Okay. So this can be solved, and what answer you will get when you solve this linear differential equation? Which value we are going to get? Which value we are going to get after solving this linear differential equation?
Sir, electromotive force, EMF value.
You will get electromotive force.
So basically the voltage.
Current.
Okay, what I will do is I will write down this differential equation dy by dx plus p into y is equal to q of x. Q simply. Which value do you get when you solve this? Which value do you get when you solve this?
The value of current.
No, no. In this, what do you get?
Y.
Y. So you get
Well,
y in terms of x. Okay, this is nothing but the solution of this differential equation. In the first lecture, we studied the solution also. So while solving a differential equation, you find out the value of the dependent variable in terms of independent variable. So in this case, what we are going to get is I is equal to some function of t. So what do we get? We get current here. Current at any time t. At any time t.
So, excuse me, sir, your voice is a bit lagging.
Is it so?
Yes, sir.
Better change the network connection and see if it's possible.
yes, sir.
Maybe you have this cyclone going on. That's why you are not having good connectivity.
Many of us are facing issue
That,
because of that.
it may not be the problem from my side then. है ना?
Sir, many of us are facing the same problem.
अरे, कोई बड़ी बात
Also,
नहीं
you
है.
are audible clear.
So you may be having this issue.
पढ़ा रहे हो ना, फिर वो
But
सुनाई नहीं देता। आप समझो, आप दो सेंटेंस बोल, एक सेंटेंस सुनाई दिया, फिर 2 मिनट बाद दूसरा सेंटेंस सुनाई दिया, वैसा हो जाता है बीच।
अच्छा. Don't worry if you have this issue
सर
today.
मेरे एंड पे पर क्लियर सुनाई दे रहा है।
Yes, sir.
That's what I'm saying. If you have this issue, you later go through the video on YouTube. Anyhow, I'm uploading all the videos there. है ना? For today's lecture, you just give the attendance and later find some time. This is not that difficult actually. So we are just applying the knowledge that you have done in the previous lecture. That's all. We are summing up your electrical knowledge and this mathematics, and we are going to solve the example. That's it. Okay. Fine. With this, I will write down one remark here. So we can get the maximum current, I max. The maximum current we can get by the formula limit t tends to infinity of I. Okay. So if I take the limit t tends to infinity, then I will get the maximum current. Okay. Please note this down so that we will discuss one more circuit and go for examples.
Can you repeat the remark?
Remark is written here. I max is equal to limit t tends to infinity of I. So the maximum current we will get by taking limit t tends to infinity. Next circuit, RC circuit. So we have the capacitor, we have the resistor, R, C, minus, and E. Who is going to tell me the differential equation? Use Kirchhoffs law. What is the voltage drop across the resistor? IR
IR.
I
plus
plus R.
the voltage drop across the capacitor, Q by,
Q by C.
Q by C.
and this has to be equal to the applied electromotive force E. Now my question is, how do you convert it? We know that the current is nothing but the rate of change of charge. So this will be R into dq by dt plus 1 by C into Q is equal to E. So we have got a linear differential equation once again. The solution for this will be, from this, what we are going to get. If you solve this, what you will get?
Charge at any time.
Charge.
Charge in terms of time. Okay. But if the question is find the current, then what we can do is to find I, what we'll have to do?
So differentiate with respect to time.
No. I is equal to dq by dt. Q is something that you have and you need to find I. So Q will be equal to, oh, sorry. Yes, you're right. I is equal to dq by dt. So these two things are possible. Okay. These are the two circuits. Next is one formula that will be encountered in your objectives maybe. And this formula will play a major role in our further studies also. Further studies, I mean to say, the next modules that we'll be learning, especially the third one, the biggest double and triple integrals. Suppose this is something that CBSE students have done, even state students have done. So e to the power 80 sine of Vt is equal. Anyone knows the formula? Of course, you can solve it by Liet rule, but there is a standard formula.
Sir, e to the power 80 into sine 80 plus b.
E to the power 80 into
Sine 80 plus b.
yes, actually, but what is b then? No, you're not right. Actually. B is this sine 80. So the formula is, I'll write it down anyways. No issues. E to the power 80 upon e square plus b square in bracket a sine bt minus b cos bt. Integration e to the power 80 cos of bt dt. This is given by e to the power at upon a square plus b square in bracket a cos bt plus b sin bt. Look, if you want to remember this, of course, you don't need to remember this. You can derive it anytime whenever it is required. But still, so you can see that if there is sine, then sine is written first here. If the integration is for e to the power at cos bt, then cos of bt is written first. Then you have this order preserved a b a b. Just changes the sign between them. When there is sine of bt, then there is minus sign between the two terms. And if there is cos of bt, then there is plus sign. Okay. This can be further modified. How can it be modified? Say if I will put a is equal to cos phi. Let's see if you could just a minute. If you put say a is equal to cos phi and b is equal to sin phi, can you tell me what will be the change? Put a is equal to cos phi and b is equal to sin phi in the first formula.
Sir, it will become a formula of
Sine bt minus phi.
sine. Yes, sir. Sine
Yes.
a.
Sine of bt minus phi, where phi is nothing but the phase difference.
Yes, sir.
So if we put a is equal to cos phi, b is equal to sin phi, then this can be written as e to the power at upon a square plus b square sine of bt minus phi. And this is the formula that someone tried to recall. So phi is equal to tan inverse of b by a. So even this formula can be used, integral e to the power at sine of bt. Fourth one, integral e to the power at cos of bt. No, this has to be under root, sorry. This change will be there. Yes, can you make the appropriate changes in the second formula and identify? We'll put a as cos phi, b as sin phi, and there is addition.
Cos bt minus phi.
So
Cos
this will
bt minus phi.
cos bt minus phi, where phi is equal to tan inverse b by.
B by.
So these are some important formulas. Now we'll go for some examples. Examples are easy. I mean, one example can go. For example, in a circuit, given L is equal to 640 henries, resistance is 250 ohms, and electromotive forces 500 volts. I is equal to 0 when T is equal to 0. So initially the current is 0. Find the time. Find the time that elapses before current reaches 90% of its maximum value. Which circuit is it? It is LR circuit. So in a circuit you have L and you have R. So voltage drop across the resistor is Ri plus voltage drop across the inductor L into di by dt. This is equal to applied electromotive force. Okay. Now we'll put the values. So we'll have 640 di by dt plus 250 into I is equal to 500. We have to solve this linear differential equation. So let's adjust the terms. So di by dt plus 250 by 640. So 250 by 640, 25 by 64 I is equal to 500 upon 64. That will be 50 upon 64. Right?
Yes, sir.
Now, how do you solve this? First of all, find the integrating factor is equal to e to the power integration 25 by 64 dt. So what do we get? E to the power 25 t upon 64. This is your integrating factor. So the solution is I into integrating factor e to the power 25 t upon 64, which is equal to integral, or the right hand side, 50 upon 64 e to the power 25 t by 64 plus c. This is how the solution of linear differential equation is. Then let's integrate the right hand side. By 64, this is equal to 50 upon 64 into 64 upon 25 e to the power 25 t by 64 plus c. So this 2 gets cancelled out, 25 2. So what is I? I is equal to, send this on the other side, we'll get 2 plus c into e to the power minus 25 t by 64. Any problem up to this?
No, sir.
No. Now what is given? I0 when t is 0. So this type of condition, even if it is not given in the question, you can assume this in order to get the value of this integrating constant c. So we'll put the value here, rub this part. So I is 0 when t is 0. So by this condition, we'll get c is equal to minus 2. So we get I is equal to 2 in bracket 1 minus e to the power minus 25 t by 64. What is asked now? Now let's get to, look, some questions are going to be like this. Find the current at any time t. So you have to go up to this in that case. Okay. This question is a bit extended. It's not just going up to finding the current, it is going beyond the current. You have to find the maximum value of the current. What will be the maximum value? Imax is equal to, anyone? What is Imax? I've given this remark. How do you get the maximum current?
So t tending to infinity.
So when t tends to infinity.
So limit t tends to infinity 2 minus 2 into e to the power minus 25 t by 64. So if t tends to infinity, what will be this? E to the power minus 25 t by 64 is nothing but 1 upon e to the power 25 t by 64. If t goes to infinity, this denominator will go to infinity, right? And 1 upon infinity becomes
0.
0.
No, no.
So this value is going to be 2, or 90% of 2 is nothing but 90% of Imax is equal to
1.8.
1.8. So we need to find the time when current will be 1.8. So to find t when I is equal to 1 point, so to find t when I is equal to 1.8. So 1.8 is equal to 2, 1 minus e to the power minus 25 t by 64. So 1.8 by 2, 1.8 by 2 will be equal to 1 plus e to the power minus 25 t by 64. So that 2 we can adjust, and that will be 1. Okay, let me write down the final calculation here. So this 2 e to the power minus 25 t by 64 1 minus 1.8 by 2.
0.1.
So 0.1 is the answer? Don't think so. This one you are saying 0.1. Okay.
So is the answer 2.56 seconds?
No, no. Which log you are using?
Oh, sorry.
So t is equal to minus 64 upon 25 log of 0.1, which is nothing but 25 upon 64. Oh, sorry, not that. 25 by 64. That will be 64 upon 25. So 64 upon 25 log of 10. Use log to the base e. Okay, then you will get the correct answer. Remember that whatever log we get in an integration, it is always natural log. Okay, not log to the base 10. So what is the t? Anyone?
5.89.
5.89. Exactly. 5.89 seconds. So after 5.89 seconds, we'll get 90% of the current. Okay. Next. Example. E is equal to 200 e to the power minus 5t. R is equal to 20 ohms and C is equal to 0.01 farad. Find the change, charge and current. Find charge and current. At any time t. Or the differential equation, which circuit it is? RC circuit. You can see R is there, there is C. So voltage drop across the resistors I into R plus the voltage drop across the capacitor Q by C. This is equal to the applied electromotive force. To make this differential equation, we note that the current is rate of change of charge with respect to time into R plus Q by C is equal to E. Let's put the values. R is nothing but 20 dq by dt plus Q upon 0.01, which is equal to 200 e to the power minus 5. So dq by dt plus 0.01 is 1 upon 100. So this will become 5, I guess. 5 into q is equal to 2, 10, 10 e to the power minus 5. So to solve this, what is the integrating factor? Integrating factor is e to the power 5t. Please check the calculations. The solution is, so dependent variable is charge here. So q e to the power 5t is equal to integral 10 e to the power minus 5t into e to the power 5t dt plus t. This two will get cancelled out. Then what is to be done? Utkarsh, mute yourself. So we'll get the charge here. Charge is nothing but q is equal to q into e to the power 5t is equal to 10t plus t. So q is equal to okay, let's not go to it. What is the initial condition? Look, I need to find the charge and the current in terms of time, but there is an integrating constant. I told you while we
So
were
that
solving.
t is equal to 0, q is equal to 0.
So when t is equal to 0, q equal to 0. So we'll get c equal to 0, right? And hence q will be equal to 10 t e to the power minus 5 t. This is the charge. What will be the current? So I is equal to, so I is equal to dq by dt. So this is going to be 10 bracket e to the power minus 5t minus 5t e to the power minus 5. This will be the current. Fine. One example for your homework that you can try is a bit different. So given the LR circuit is given by L into di by dt plus R into I is equal to 10 sin t. Find I as a function of t. Yes, what is the difference? Can someone tell me what is the difference between previous examples and this?
So here the integration will be of the form e raised to 80 sine of bt.
Yes, that is one case, but from electrical point of view, can you say something?
So we don't have any values.
Okay, let's say I give you the values, those are constant numbers.
So
Those
the
are
current
constant.
will be of AC type, maybe.
Yes, AC term. So applied electromotive force that you have here, it is variable, right? There is sin t. In the previous examples, whatever we have seen, in that case, applied electromotive force was constant, like 500, and this kind of things were there. But in this case, our
No, sir,
applied
in the last one, it was dependent on T.